The scheduled commuting time on the Long Island Railroad from Glen Cove to New York City is 65 minutes. Suppose the actual commuting time is uniformly distributed between 64 and 74 minutes. What is the probability that the commuting time will be A, less than 70 minutes, B, between 65 and 70 minutes, C, greater than 65 minutes? First thing we notice is that the times are uniformly distributed between 64 and 74 minutes. So it's a uniform distribution, and I want to create a uniform probability density function. So according to the procedure for that, I'm going to set f of x equal to 1 over 74 subtract 64, or 1 over 10 for all x between 64 and 74, and 0 elsewhere. I could also graph this density function. It is a horizontal line over the interval from 64 to 74. So 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, and 74. And the height is 1 over 10. So I'm going to draw this horizontal line over the interval from 64 to 74 at height 1/10. Notice that the area under this line above the interval is 1. It's the length times the width. It's a rectangle, and it is 1. 1/10 times 10. So our probability density function is in the graph here. Now, to work on our first question, finding the probability that the commuting time will be less than 70 minutes, that's A. Probability that the random variable x is less than 70 minutes. Okay, so I want to find that probability. The probability is the area under the density function above the interval. So less than 70. So we would have 70 is right here in our number line. And the area under the density function below 70 would just be this. And that is the probability that the random variable x will be less than 70. So to calculate the area is to calculate the probability. And since the area for a uniform distribution is in the form of a rectangle, then it's just the length times the width. So I would say 6 times 1/10. Difference between 70 and 64 is 6. And then I have a height, or maybe the width, you could call it, of the rectangle, 1/10. And I would have 6/10, or 0.6, which is also 60%. So the probability that the commuting time will be less than 70 minutes is 60% probability. Okay, B. What is the probability that the commuting time is between 65 and 70? Probability that the commuting time is between 65 and 70. Okay, where is that interval? 65 to 70 is, 65 is right here, right above the 64, and to 70. So what is the area over this interval below the density function? I'm going to shade that in blue. And that will be, the probability will be that area. And 65 to 70, that's 5 units. And again, 1/10 to give us the area of that rectangle, which again is the probability. I'll have 5/10, or 0.5, which is also 50%. Okay, C, the probability that X is greater than 65 minutes is equal to, in this case, that would be the interval from 65 forward. So we'd be talking about the entire line from 65 on. Notice that extends beyond 74, but there is no probability of being above 74, or the probability is 0 above 74. So to get above 65 is, again, just the area under the density function above the interval. Total sum. So I'm going to shade that in black. And I have to calculate that area to calculate the answer. So 65 to, we'll stop at 74. There is no added probability above that, so we only need to go to 74. So 65 to 74 is 9. And then times the 1/10 is 9/10 equal to 0.9, which is 90%.